All right, welcome everyone to the CIGRE Next Generation Network webinar on software as a service and the electric power grid. My name is Hassan Idris. I am the professional development webinar chair for CIGRE NGN, and I want to go over a few housekeeping items to ensure we have a quality call today. We will hold our questions until the very end of the presentations, so we thank you for muting your line upon entry. You can use the chat feature to ask questions. We will have them read right after the presentation. We are recording today's presentation, so please be cognizant that anything you say will be recorded and posted on the CIGRE NGN webinar page once the material is ready. Today, we are fortunate to have Astrid Atkinson with us. Astrid is CEO and co-founder of Camus Energy, which provides software-based grid management as a service, combining real-time situational awareness, device control, and market integration for grid operators and energy providers. Prior to founding Camus, she was a senior director of software engineering at Google, where she was an early leader in distributed systems reliability. As lead for reliability engineering for Google.com, she led the development of Google's global web serving platform. And as head of frameworks engineering, she led the development of a common, performant, scalable set of infrastructure frameworks, which now power all of Google's major product lines. She speaks globally as an expert on large-scale distributed systems architecture, reliability engineering, and organizational leadership. I've had the pleasure of listening to Astrid's talks on risks of surrounding distributed systems, and it was an informative experience. With that, I would like to hand the call over to Astrid. So if you could give me a minute, I will run her slides and then we can take a look at that.
Fantastic. Can you guys hear me okay?
We can. Okay,
Awesome.
we have your slides up here. So I'm going to move them for you, Astrid, as you can
Okay,
tell me.
fair enough. Thank you so much. I really appreciate it. You want to move on to the first slide and I'll do a bit of an intro?
Sure.
All right, so I'm Astrid, as advertised. I'm the CEO and one of 3 co-founders for Camus Energy. Our company's about 3 years old, and the goal when we founded it was to bring some of the expertise and technical approaches developed in high reliability distributed systems design and implementation and operations from companies like Google, Facebook, Uber, SpaceX, etc. There's been a lot of really groundbreaking development in the computing and distributed systems space in the last few years. Because of the way that's happened, that's really mostly happened in the commercial space. Today, the research space for computer science really doesn't have nearly as good a handle on how you build kind of big, reliable systems as the commercial players do. And that's because a lot of that R&D really happened in the field. And I was fortunate to be part of that at Google when they were developing their cloud computing model, along with Cody, our CTO, who I worked with for pretty much the entire 15 years I was at Google. When we built this team, we were really looking to bring together a mix of skills. Some folks who are great at big distributed systems, some folks who are really deep in the energy sector and really understood the grid management, and the energy industry and ecosystem. And some folks like our co-founder, Michael, who have an enterprise background and really understand enterprise and software as a service models. And the goal for that was really, like I said, to sort of leverage that world-class software expertise in the service of an area which I think is probably one of the most important in the world today, and that's why I chose to work on it, which is transformation of the grid to support rapid decarbonization and effectively incorporating a really large kind of variety of low or zero carbon resources as we look to make big changes to our energy system. Next, please. So, if we think about like the shape of that problem, the traditional kind of glib answer for decarbonization, at least of the energy system, is really 2 steps. One is electrify everything. Step 2 is decarbonize the grid. And that means that our usage of our existing energy system and the role that the grid plays needs to change as we move forwards. Now, it's always up until now been a roughly instantaneous management environment where at any given time you've got generation and consumption which are equal to one another, balancing out the supply and demand side of the grid. But as we switch to renewable, variable, and different energy sources, whether that's geothermal or methane capture or biomass or wind or hydro or solar or whatever, increasingly we have an environment where the place and time where energy is being produced may not necessarily line up 100% with the place and time where it's needed. And so that means that balancing within that system, it involves managing consumption as much as it does production. It also means taking advantage of storage, time shifting, flexibility, etc. Um, but it also means putting together a lot of disparate pieces. The good news is that the connectivity that we would need to make that possible is already out there. We have the grid that connects pretty much all sources of supply and demand. It's just a matter of using it differently. Next slide, please. One of the things that makes this really difficult in today's grid environment is that the state of the art for utility software and grid management software is pretty old. I mentioned that there's been a lot of groundbreaking development in the consumer tech and kind of deep tech space. And it's maybe not a surprise that that's a little slower to make its way into the grid management landscape, because utilities are conservative for a reason. It's their job to keep the lights on. And if you've ever been in an operations role, you'll know firsthand, and certainly I've been there, that when your job is to keep things working, the last thing you want is rapid, innovative, untested change. So it's kind of a standing joke within the utility space. Most utilities will often tell you, like, they don't want to be the first to adopt a technology, they want to be the sixth. And then they'll mutter something like, actually, I really want to be the 26th. And the reason for that is they want to know it'll work. But that also means that access to technologies that are really needed to solve a lot of today's grid management problems, managing a lot of data, managing a lot of scale, managing a much more diverse array of interaction points on the grid. Those technologies really aren't easily available in today's utility software landscape. And it's very difficult to make that jump from software that runs on, a couple big servers on-prem to the sort of scale that can manage even just bringing in all the data from the smart metering system. And so this is something that the utility industry has been really wrestling with, especially as, they've invested in instrumentation that brings in more data. The backend systems that could potentially manage that just really, they're not there yet. Putting all of your AMI data into an Oracle database is definitely, at this point, 15 or 20-year-old solution. And in order to really manage that and take advantage of it, you need to do something different. Next slide, please. So that's kind of what we set out to do. And when we started the company, we spent a lot of time talking to folks at utilities and elsewhere in the energy industry, distributed resource manufacturers, consumer advocates, policy people, those kinds of things. Just trying to understand, where are the leverage points for change? What would be most helpful? When I started this company, I imagined that we'd be leveraging technology developed at Google for managing millions of resources in a 5 nines reliable system. And what I quickly realized when talking to people in the utility space was basically, what I heard over and over again was basically, manage it, we can't even see it. One of the things that is really different about the kind of large-scale distributed systems approach that we're used to working within, and that companies like Google and Facebook and Uber and so forth all run on, is that it's fundamentally driven first by collecting all the data, and then by managing it, making it useful, making it accessible and informative to the people who need to interact with it, making it friendly to customers, making it friendly to people who need to do their jobs. But that all really starts with the data. And so that's where we started as well. What we heard loud and clear was that utilities needed tools to incorporate, understand, and make use of that data, understand what was happening on their grids. And only then would it really be very valuable to start looking at things like control problems and sort of large scale transformation problems. So that's where we started to. We started by working at whole grid scale with some early customers, and I'll talk later in this talk about our kind of commercial progression and how that's worked for us as a company. But really with incorporating the data, pulling it all in, understanding it, making sense of it, building tools to make that accessible to operators, and then building tools to better understand, to analyze, forecast, and build a really nuanced understanding of what's happening within the grid environment. Our platform also then can manage resources with that incorporated grid knowledge. And something that we're working on now with a couple of our pilot customers is, or sorry, not pilot, but newer customers, is incorporating those resources into markets and into market-based incentives for customer resources. And I'll talk in a little bit about why we do that, but the short answer is really that there's a certain number of resources out there on the grid that you can reach with a command and control model, and a whole lot that you can't. And so then the question becomes, how do you get all those resources to do what you want? And that's where market integration models, whether that's wholesale or local, become really critical. Next slide, please. So within the utility industry, there's, I would say, like, a pretty broad awareness of the sorts of changes that might need to happen. A lot of discussion around how to leverage and incent third-party resources within the grid environment kind of circles around these ideas of different pricing structures, potentially dynamic real-time rates, potentially local markets, looking at market integration, looking at much more real-time and proactive management of the grid. And the way that I like to think about this, and this is also something that has been a topic of frequent discussion within the utility space, is this idea of kind of extending the capabilities that an independent system operator has today around real-time visibility, real-time grid management, management of grid constraints, management of supply and demand, and financially structured integration of resources, and make that available at the distribution utility level. So this is a kind of distribution system operator model. There are a number of different ways that this could play out, and we're seeing this happen in different ways in Australia, in the UK, in New York, in various places within the US. But this is really a new enough idea that I don't think there's any really canonical implementation of any one of the possible models yet. Still, this idea that you need these real-time management capabilities, whether that's spread across multiple parties from like retail utility poles and wires provider to ISO, or whether that's really encapsulated in a single utility, whether that's the distribution utility or extended by the ISO, kind of captures this idea that you need real-time management within this grid environment, and that it needs to cross over some of the traditional boundaries. So this is not just about like, how do you roll trucks and dispatch line workers to resolve outages? It's not just about, how do you prevent solar rooftop PV from doing damage to the grid? It's not just about like, how do you manage the integration of aggregators like thermostats or hot water heaters or batteries or whatever into the wholesale market. It really kind of needs to cover all of those things because it all exists within one system. And it's very difficult to get system level behavior without system level awareness and at least lightweight coordination. Now that's different than system level control, and I'll talk about that in a little bit. But that's basically the kind of the core philosophy that we came in with, is that the role that we want to take is providing these extended capabilities within the distribution environment. Next slide, please. So what does that look like in practice? As I mentioned, there's a lot of different models that this type of evolution could potentially follow. Who has access to the poles and wires part of the grid? Who manages the retail relationships with customers? Who owns the generation? Are they allowed to own batteries? Are they allowed to install EV charging infrastructure? That really varies market to market and between regulatory environments and between sectors within the utility space. But one of the things that we realized early when we were talking to folks in the utility space is that not all utilities operate the same way. They don't all have the same incentives, and some segments are more incented towards change than others. So we actually started out working in the public power sector, and that still represents most of our customers to date. We'll again talk about that a little bit more when we get to commercial strategy. But what we found was that there was a subset of folks in the public power sector, particularly co-ops, that were moving really fast towards making these kinds of large scale system changes. And this customer, which was our first one, is a really good example of that. They're a local distribution utility in northern New Mexico. They serve the area around Taos, which is a community that has both very wealthy and very poor residents. So it's an interesting microcosm of some of the energy equity issues that are arising across the United States and other countries as we're kind of looking at this shift towards large scale renewables. And they were seeing a situation that's very similar to what many utilities are seeing, only they're small, so it was pressing. And that was that a lot of their residents who could afford to were putting on rooftop solar. They were now being compensated under net metering, no longer paying the rates that they used to. And they were concerned that that was going to mean that the costs of the system would end up being borne by all of the other residents who couldn't afford it. And so they decided to get ahead of this by really pushing from within the utility to invest in local renewables, local solar. And they went to a lot of trouble on this, and you can Google them. It's kind of an interesting story. They broke their GNT contract. They put in a lot of local renewables. But once they had done that, and once they were kind of on a path towards doing that, they really rapidly ran up against the next problem, which was that meant running their grid entirely differently. So that's why they wanted to work with us, even though we were a very, very young company at the time. We were only a couple of months old. Because the capabilities that they needed around managing a grid with 100% solar during the day were really just not easily commercially available. And so we've been working with them for several years. They are very close to achieving this goal now. When their last arrays come online that are in their final stages of development now, they will exceed it. And they're unusual in a lot of ways, but I'm also very hopeful that they're going to be setting an example for what's possible when you really sort of commit to it and decide to do the work. Next slide, please. Another example, and this one I love because this is a place where they're incorporating a lot of behind the meter resources, is another co-op, not that far to the north, actually, from Kit Carson and Taos. Holy Cross Energy serves the area broadly around kind of Aspen and Vail. They're based out of Glenwood Springs. And they are a utility with quite a bit of sort of large scale load, primarily from tourist industry and snowmaking within their territory. They're also a community that has, like Taos, a lot of folks advocating for clean energy, really looking to kind of push the envelope on the energy transition. And they're a wealthy enough community that they can kind of afford to invest in these technologies, and have customers sort of clamoring to be able to have their resources like EV charging and thermostats and so forth managed by the utility, which is kind of an unusual situation. They have a really innovative and forward-looking program around incorporating behind-the-meter resources, particularly focused on EVs and battery charging. And they use these resources on several times a week basis today to do peak shaving within their power contract structure. They actually stand to save a lot of money on shaving narrow peak windows. And for any utility where that's true, demand management within those peaks is kind of an attractive proposition. Again, this is something that is particularly interesting to them because they're a public power entity and because they have the right kind of energy supply structure. But they're, as I'll talk about it in a little bit, also particularly forward-looking and looking to use this as an example for other utilities and really kind of pave the way with this. Next slide, please. Third and last example I'll give as we go through current customers today is another cooperative utility, also in the kind of New Mexico, Colorado area, which is interesting because there are actually quite a lot of small utilities there, and they're pretty independent and also pretty forward-thinking. And this one's like kind of in between, actually. They're not really looking to fully decarbonize their grid today, although they would love to do that in the future, like many other utilities. Today, they really just want to make better use of data. They want to get set up for the change that they know is coming. They want to be able to put plans in place to make big changes over the next 5 to 10 years, and that's something that they're doing right now. But this is a really good example of the foundational data integration and analysis use case that I mentioned in the kind of intro section, because they really just wanted to start it by understanding what's out there and having the tools to manage change as that began to accelerate for them. We'll talk a little bit about what that looks like in practice. Next slide, please. So the kinds of things that utilities might want to know but don't have great access to on the distribution side today is, firstly, what's happening at the substation and feeder level. That they typically have good instrumentation on through SCADA. Many have rolled out smart metering systems. Those are typically two totally separate data systems. In general, you have to invest in an advanced distribution management or ADMS system to bring them together. Not all ADMS systems do that either. And that's kind of a shame, because when you put those two things together, it's really easy to understand what's happening everywhere on the grid. And if that's something that you need, which is increasingly the case in a utility that's looking at a lot of change, then bringing those data sources together provides the opportunity to answer a lot of questions that utilities start to have. Where on my distribution grid do I have issues with equipment such as transformers? Where on my distribution grid should I be concerned about interconnection requests, and where can I just go ahead and say yes? Where do I need to think about upgrades? If people are looking to do local resource development, where should they go? Being able to answer questions about what's happening across the whole grid makes these kinds of questions that utilities have a lot easier. And it also provides a certain level of comfort, right? When most distribution utilities today, when they're looking at changes, they'll commission engineering studies and look at the potential impact over a number of years for adding a battery or adding some EV chargers. But what's increasingly happening is that they have changes coming from a bunch of different directions. They've got rooftop PV moving loads around. They've got behind the meter EV charging moving loads around. They didn't do an engineering study on all of those things, and it's hard to do all of those together. And so you can definitely get into a situation where there might be unexpected impacts on the grid. And what our utility friends tell us is that being able to see that if it happens and react to it, not even necessarily minute by minute, but even just week by week and month by month, really makes it easier for them to think about allowing that change to happen, much more comfortable for them to go ahead with a project. Because they have the knowledge that if issues do arise, that they'll be able to see it and they'll be able to take steps to mitigate it. Next slide, please. And one thing that's really helpful to them is for that data to be inclusive of behind the meter resources and the new assets that are being added as well. For utilities that do have a lot of customer resources, customer programs, local generation, etc., pretty much all of these systems have some way to understand what's happening with them. They pretty much all have a dashboard or a console or something like that. But once a utility started to invest in a few of these things, that can mean like 3 or 6 or 12 dashboards that somebody would have to look at. It's not really anybody's job, at least within the current utility structure. And it's also a pain in the ass to really understand what's happening. If you look one place for the battery console, one place for the EVs, one place for the solar generation, one place for your voltage analysis, it's kind of hard to put the pieces together. So that's also what we do. We put all those pieces together. We'll take data in directly from the customer or third-party resources, as well as from the utility resources. And that means that we can provide a really nuanced view of what's happening with the customer, what's happening with generation, if they have it, what's happening midline on the grid. And those things can combine to power higher level operations, whether that's direct control of resources or whether that's actions that humans take. Next slide, please. And so, one of the actions that a utility might take, and this is particularly relevant for those smaller public sector utilities, is managing an increasingly disparate procurement environment. Managing energy costs if they're integrated into a market, managing contract costs and peak costs if they're on a peak contract structure, and thinking about the role that local resources and flexibility might play is a lot for a utility to think about, especially if they don't have anybody whose job that is. Now, a lot of utilities outsource this through a G&T or some other structure. But increasingly, if they want more flexibility, they're left doing more of this themselves. And that's kind of a pain in the ass because they're small entities and this is complex work. So one of the things that we've been doing with our public sector utilities is working with them to integrate tooling around this that supports their power supply team and their power procurement team as they look at ways to think about incorporating newer resources alongside the ones that they're already managing. So a lot of that is forecasting. Some of that is also cost management. We do net load forecasting. We do coincident peak forecasting, which is very useful for customers today. We're also increasingly doing a lot of work around understanding loads and forecasts at the individual customer level. That adds up to a number of technical advantages when we start to look at things like control, but those are more forward looking, so it's not really something that we sell on for current customers. Next slide, please. What we do, though, is translate that understanding into control of resources. We can do that either directly by talking to a customer resource or a utility resource through a traditional interface. We can also do that indirectly by talking to an aggregator or to a device API. So the tricky part here is really just making sure that the contract structures are in place to allow us to speak to those devices. But they're really, every single one of them does have somebody who is looking at the device, managing it, and generally looking to make some money on it. And so this is where looking at also pricing and market structures become really attractive because there's some number of resources that we can reach through utility programs, but in the limit, we really expect that being able to provide opportunities for all those resources out there to make money is probably the best way to get them on board and cooperating with the behaviors that grid operators need and the behaviors that can benefit the customers who host those devices. Next slide. And so what does that look like in practice? Well, there's a number of ways that customer devices can be valuable. One of the simplest is just energy provision. So peak shaving is one way to do that. Dispatching of resources into wholesale markets is another way, although that's not really available in most wholesale markets today, not within the US anyway. In the UK, there's models that allow this at the moment. Other potential options are paying customers for flexibility that's valuable in other ways. Such as managing load on transformers, substations, feeders, or other parts of the physical grid. Those are typically capital deferment workflows, but that's where the requirements around data and control reliability become really serious because there's no way to really effectively pursue a capital deferment or capital avoidance workflow, where you're looking to use software management to avoid upgrading a substation or a transformer or something like that, unless you really, really, really trust that the control will do what it says it will. So that's where the grid-aware control becomes really critical, both to providing guarantees of reliability and also to understanding the value of those services. And this is what we're in the process of building with some of our early stage new customers today. Next step. So that's kind of an overview of what we do. But I promised to talk about SaaS and why we use this approach and how that's working for utilities. So I figured I'd go through and talk a little bit about the SaaS model. Why do we need it? How do we sell it? What are the concerns about it? And what are the benefits? You want to go ahead to the next slide? So the basics of what we do are, they're sort of a lot from a technical perspective in terms of data integration, management, and system capabilities. But the process by which we integrate this with a utility and manage it for them is actually very simple. Because we're a SaaS company, they don't have to install all of this stuff on site. They don't have to get it working themselves. It requires a lot less work from their IT team. Doesn't require an entire dedicated team of integrators, which is typical for an ADMS deployment, even a small one. We do that, and it's part of the cost of the service. There's a services component that's set up, and that's data integration and connection to devices. And then there's ongoing maintenance. The utility still needs to use the console and take actions with it, like whether that's like looking at forecasts or scheduling peak events or setting in place, capital avoidance policies, those kinds of things. But the work of like making sure that data is still flowing, making sure that, if like device firmware changes, we can still talk to it, that the servers involved are up and running, that it's providing reliable service. That's a SaaS service. That's how SaaS companies work, and that is what we do. And so that's why we really focus on a subscription model, because there's a fair amount of ongoing work associated with doing all of that, but there's also a lot of benefit. So one of the benefits, of course, is that it's a bit easier for a utility, and especially for smaller utilities, that's kind of a plus. But another is that when we make changes to our product, that's something that doesn't typically benefit just one utility. It usually will benefit all of our customers. And of course, you need to manage this within a change management cycle. You don't want to be rolling out changes that might impact people's day-to-day work at the utility without warning them, or going through like training and all of these things. But the fundamental benefit to both us as a product company and also to the utility being able to incorporate rapid advances in technology, capabilities, devices, etc., like as part of the package is really huge. And that's why people like SaaS, because it evolves as the problem space evolves, and you don't have to go back and reinstall something new over another 10 years in order to make that happen. Next slide. Um, all of this means that at least, as we got started as a company, we were looking primarily for customers that were interested in trying something new, that had problems that weren't addressed by the existing vendor landscape, and that were actively interested in partnering with a small company to solve new problems and to develop new solutions within the space. And so this has worked really well for us. Some of the early utilities that we've engaged with have some of the most aggressive decarbonization goals in the country. They're really pushing the envelope on what's possible and what's in practice out there on the grid today. And because they have goals that they're looking to meet in the short term, and because we take a data first approach that's, first non-disruptive and then highly informed, we typically skip a small scale pilot and move straight to full scale deployment for data infrastructure. And then we do a guided, very rapid pilot process for rolling out control, which allows us to go kind of all the way into production with these resources very quickly. And so, even though we're only 3 years old, we've been managing behind the meter programs in the field with one of our customers for about a bit more than a year now. And we have 3 years of data with our earliest customers that we can use to inform, our work on more advanced analysis and control capabilities. And that's been really a fundamental accelerator to us as a company as we build solutions that can work for more and more customers, for bigger customers, and can start to tackle the really important problems in the space around thinking about what it looks like to run that like next generation, highly customer involved two-way grid. So as I mentioned, kind of the next frontier in that really is focusing on that monetization model and that real-time incentive control model. And that's something that we're set up to do because we have customers that want to do that today, and we have the data that can inform that development. And so that's something that's under development for us now. Next step. However, that's not the entire market, and that's not necessarily how you're going to build a whole business. The market is not entirely made up of real innovators and people who want to push the envelope, particularly in the utility space. The vast majority of the market is made up by people who want to make or save money, who want to provide really reliable service, and continue to be the backbone for their community that they always have been. And so when we talk about what we do, we really kind of focus on that control piece, managing change, making it safe, supporting reliability, supporting resilience, and managing costs, because that's really how most utilities procure today. And so I bring this in not to reiterate what we do, but just to talk about like what's messaging look like? Like how do you talk to utilities about why you might want this? And why this is a good idea for them, even though it's kind of new and potentially not necessarily something that 100% of their neighbors are doing. Next slide. One of the biggest ways that we can do this and that we kind of message and sell on what we do is by leveraging the relationships that we do have with our early customers, and with other folks who are really interested in thinking about what next generation utility operations and business models could look like. Um, this slide actually comes from a utility that's not a customer, but a utility that's led by a CEO that did a lot of early work in grid modernization with APRI. And I loved it so much that I asked if I could borrow it, because it's really sort of starting to explain, to a utility how what we do can be additive to what they might need, and how it can replace some of the places where they might have invested in other systems, and potentially help them to get ahead of some of the problems that are coming. So we often sell, we generally kind of sell for smaller utilities, to folks who are considering an advanced distribution management system deployment, but are also interested in being pretty proactive about putting in, customer resource programs, market integration programs, and really looking at that kind of next generation business model. Because while we don't do all the things that a full featured ADMS does, also many utilities don't actually use all those features. And we do a number of things that they don't, including distributed resource management, forecasting all the way from individual customers up to the whole grid level, and supporting that kind of forward-looking market integration model. And so this is something where, working with existing utilities who want to trailblaze this, they can then tell their cohorts, the other utilities that they work with, about how this worked for them, what programs they put in place, what results they saw, how they structured their programs, how they worked with us, what that was like. And so it's heavily reference driven, in terms of how our sales and business development works, but it's also pretty results driven, and that's really nice. And that's one of the really core advantages of that SaaS model, because it just lets us move so quickly and produce results that are real, actionable, and referenceable, in a relatively short amount of time. Next slide, please. A couple of the other sort of underlying points that I made earlier was sort of talking about how the traditional utility software model kind of can't get utilities where they need to go. And this is where, when we talk to small utilities, that's one thing, because, they're potentially looking to procure within the ADMS space, but are interested in thinking about forward-looking models, and they often don't have an existing ADMS deployment. When we talk to a larger utility, we're not going to replace an ADMS for them, at least not today. We're still, we're pretty young, we're a small company, and that's a pretty big piece of software. It does a lot of different things. But we can do some things that no traditional existing solution does. And that's incorporate all grid data at full scale, never downsampling. Can all be incorporated into real-time analysis. It can all be incorporated into real-time understanding of the grid. And the reason that we can do that is that we use lots of computers. And that's basically like kind of the core fundamental advantage of the cloud. It's not just that it's somebody else's computer and you're kind of, offsetting or moving elsewhere the costs of data centers and servers and so forth. It's that you can use really a lot of computers to solve very complex problems. And that's why this model was first developed at companies like Google, because they wanted to be able to answer, search the entire internet to answer your question about how to open the trunk of a Ford Escape when you're standing in the parking lot at Hertz, which I'd like as an example because it's a problem I've really had, in under a second, right? Like I can pull out my phone, I can ask that question of the entire internet, and I can get an answer back, quickly enough that I can get into my rental car at like 2 in the morning when my flight's been delayed. Doing that requires an enormous amount of computing power. And when we think about our other really large scale challenges, energy system transformation is certainly one of them. And one of the really big problems that distribution utilities are concerned about is just managing the complexity of the distribution environment. It's so much more complex than the transmission grid. It's very open-ended. Our existing analysis technologies aren't performant in it. And a lot of folks in that space will just kind of look at it and be like, how will we ever do all this work with so much complexity in the wild, so many resources, such a complex grid. Maybe we don't exactly know its current state. Maybe it's not fully mapped. There's really a lot of data. How do you deal with it all? And this is where cloud technologies shine. This is what they were built for. And so when we talk to big utilities, and when we sell to big utilities, they're the ones who are really starting to be concerned about that scale. And this is how we talk about it. This is what we do that's different and special. Next slide. One of the really big traditional concerns that comes up when you talk to utilities about using the cloud and using SaaS solutions is cybersecurity. When I first started talking with people in this space, like probably 4 or 5 years ago, a lot of them told me that SaaS was a non-starter. They're like, okay, I recognize that maybe the cloud could be great, but cybersecurity is kind of the conversation that we were having at the time. But that's really evolved over the last few years. What I might have told them if I wanted to get into an argument 5 years ago was that the platform security the cloud can offer is typically a lot better than what you get from on-prem solutions. There are a lot of very fine services that one can procure that help really make interacting with large-scale systems a lot safer, and it can make IT systems a lot safer. It's not a silver bullet because it introduces new potential attack vectors. Anytime you're integrating a SaaS vendor, you're basically taking on the kind of transitive web of their dependencies and their security practices. So it's definitely a real concern. But at the end of the day, it's fundamentally, from a platform perspective, more secure to use Amazon or Azure or Google than it is to deploy resources on-prem. And there's increasingly high quality set of practices and services that one can leverage that make that not just okay, but potentially better. That's still a work in progress, and thinking about the compliance and certification models and so forth that are required to make that really bulletproof and really trustworthy for everybody, not just kind of the trailblazers, is still, it's still a work in progress. But what we've really seen is that for utilities that are looking to get the benefits of managing scale, really being able to incorporate that data, really understand it, really use that to power transformation in their business. They've already kind of gone through the thought process of like, well, okay, if we want the scale, we probably need the cloud. Could we use the cloud? Actually, it might be okay. And so what we actually found in practice was that this objection typically didn't come up in any real sales conversation we were having. Doesn't mean it never comes up or that it'll never come up in the future. But I would just say that, like, this used to be a blocker, and I no longer feel like that's the case. I feel like we're much more often having a conversation about the actual cybersecurity practices that we or the cloud management provider or another software vendor actually has. And it's not the knee-jerk response that it was. I think this is something that will continue to evolve. Next slide. One of the biggest challenges for doing SaaS with utilities is actually not technical at all. Getting to data, getting even real-time feeds of data is kind of a solved problem within the broader tech industry space. There are wonderful technologies for incorporating, ingesting, processing, analyzing, doing real-time analysis of very, very large data sets. And from a technical perspective, those are things that we bring to the table when we come in to work with a utility. Likewise, the cybersecurity considerations are things that you can have a conversation about. Certainly, it's a place where you want to take very seriously, and where you want to really kind of focus on managing the risk profile for the customer that you're working with and the service that you're providing. All of which is to say that, like, those considerations, they're all kind of manageable, and the advantages are really significant. The place where we do really struggle with working with bigger utilities particularly, and where I think there's still some big open questions for how our business works, how the whole business works, is that utilities have a very hard time capitalizing SaaS costs. This is something that some states allow. Within the US, there's no kind of federal model around this. And that's really important because the profit model for investor-owned regulated utilities all flows through capital investment. It's basically capitalized rate of it's guaranteed rate of return on capital investment. Um, and they're that's fundamentally at odds with procuring SaaS solutions, even when the SaaS solution is better, cheaper, and a better fit for what the utility. If they can't find a way to fit that into their business and profit model, might as well not exist. And this is something that we've been working through with early customers in the space. But whenever folks ask me, if I could wave a magic wand and change one thing from a regulatory perspective, it actually isn't anything to do with distributed resources or instrumentation or markets or anything like that. It's actually just about SaaS. Like making it possible to capitalize SaaS costs within the existing structure of utilities would really help those utilities to be able to incorporate modern technologies to solve the problems that they're really looking to engage with for their customers. I don't know that all utilities are in the same place on this, but they're going to need those solutions, and it's something that the industry as a whole really needs to address and solve. Today that we have some sort of adjusted ARR type workarounds for this, but it's still an open question for us, and it's still an open question for the industry. And this is kind of the one thing that I would flag, as a SaaS company. It is a concern. It's also one of the reasons why we work primarily with public sector utilities today that don't have the same set of incentives, and are relatively sensitive to cost of energy, because that's a place where we can really contribute and provide technical solutions that have a direct value proposition to the utility. Next slide, please. I mentioned earlier that this model has allowed us to work really quickly with our utility customers. We are only 3 years old. We're currently in the field, fully in production with 4 utility customers. We have 2 more coming on board right now. This is something where we've been able to kind of prove out what we do pretty quickly. We've gotten our customers to referenceability, and partnered with them to solve the problems that they care about the most. And we've been able to do that pretty effectively with a relatively small team. And that, as I mentioned earlier, like that's really one of the beauties of this model from a technology perspective and from a rapid change perspective, is that, like, if you're in a space that is changing in an open-ended way, like you don't know the end state that you're moving towards, it is very difficult to sit down for 3 years, write a big piece of software, have the customer take it, spend 5 years deploying it, and have that software be anywhere near relevant to the problems that are active in the field, 8 to 10 years later. That's just not possible. It's not going to get us where we need to go. And so, the closing thought that I'll leave you guys with before we move over to questions and stuff is that this iterative model that supports is critical to meeting the challenges of decarbonization and energy system transformation. There's probably no path forward without technology solutions that look more like this, because we need to iterate in the field and we don't know what the end state looks like. And finding ways to do that, and finding ways to do that in practice quickly with the people who are doing the hard work out in the field of making change in the utility space for their customers and their business and their communities. And that's the way that we do this. And so, at the end of the day, we can provide technology, but it is those partnerships with the change makers that really make this possible. And I could not be more grateful to our utility partners who have worked with us on doing this to date. It's really just been the best experience from a technology perspective. We're really looking forward to doing more work with them to drive transformation and really demonstrate what a fully decarbonized grid could look like. So I'll leave it there. Next slide, please. This is the end. And if you want to go one more forward, I'll leave my my little ad about the fact that we're hiring here at the end. And I'm happy to answer questions.
That was wonderful. Thank you so much, Astrid. Great presentation. I'm trying to check if we have received a few questions here or not. In the meantime, we did have some questions in advance. So first question we have is that, does grid saturation feature in Camas Energy Solutions, and how do you tailor that? And I understand it's a pretty generic question, so feel free to be as brief or as long as you'd like.
So congestion, which I think is probably what you mean, is sometimes a factor for distribution grids. Not as often as people imagine, because distribution grids are typically overbuilt. But you definitely will see congestion or saturation concerns in places where grids are constrained. Like there's like just one substation that serves an urban environment and they can't easily build another, or the lines are all undergrounded and it's hard to put in more. You'll most often see it in places where there's a lot of like rapid development of like more customers coming in, potentially things like EVs, but far more often comes from like just really rapid population growth or business growth within an area than from DERs. The ways that that shows up on the grid are a couple. One is looking at capacity of lines and equipment. So, for example, the transformer loading example that I gave is one of the key things that you would look at if you were worried about like the impact of changing loads on equipment midline on the grid. The other is voltage. Distribution utilities really manage to voltage. And in general, if you have issues with unbalanced loads or negative impacts from local resources, you will see that show up in voltage anomalies. And so keeping that like kind of voltage analysis really current, being able to look at that over time at certain points in time and be able to project it, that's kind of where things like saturation and congestion show up from an analytics perspective in our solution. And then on the control side, managing congestion with control policies is absolutely part of what we do. It's one of the big benefits for it.
Sounds good. We have a question from Vladimir Stapchuk. He's asking, how accurately can you forecast the load, and how does it depend on the size of the data? Is that something you can address?
We're relatively accurate. We don't today do anything particularly fancy with our basic substation load forecasting. It's effectively a linear regression. It's based on temperature, weather, and like probably 30 other factors, but it's mostly based on weather. It's fairly accurate. I don't have the specific model accuracy stats off the top of my head, but it's as good or better than the previous forecasting methodologies that our current customers were using. What we do that is kind of fancy is also do coincident peak forecasting. So that's not necessarily forecasting the peak of the utility. It's trying to catch the likelihood of any particular daily peak being also the being coincident with the monthly system peak for the energy provider. So it's like kind of a weirdly complex forecasting space that we do, I think, very well. The other thing that we do that is starting to roll out into the field now is based on some grant work that we did with Pacific Northwest, we are doing with Pacific Northwest National Lab. And that's looking at model-based or machine learning model-based forecasting in narrow time slices for individual meters. So that's looking at like up to like within the last 2 hours activity at a meter within the AMI collection gap. And within sort of day to week ahead for an individual meter that can then roll up. So we're not a specialty forecasting provider. What we focus on is basically information about the system as a whole. And in general, the more information you have, the better the forecast is going to be. And that again is like one of the big pluses of a cloud-based model. Like more information is not a problem, it's a benefit for sure.
Sounds good. The next question we have is from Michael Higginson. He's asking, how do you address cybersecurity concerns with traditionally air-gapped utility control systems when connecting them to an internet service?
Totally. So there's a couple of things, and this is like kind of probably a whole talk in and of itself. So a couple things in there. One is that in general, from a cybersecurity perspective, the last thing you want is to put customer resources on your control network. Any solution that does that is probably a horrible idea. Adding a bunch of thermostats or whatever into the same network and communications environment that your meters or substations or other equipment is communicating on, it's not advisable from a cybersecurity perspective. So we actually form part of an air gap there in the sense that we are pulling in typically read-only data from the secured network, putting that alongside with data that comes in from public comms networks, and then performing control operations based on that. Again, sometimes through public comms networks, sometimes through specific access into secured networks. Um, but the systems that we use to incorporate data and the systems that we use to manage control are also separate and air gapped. And so, you know, it is a complex cybersecurity environment, but putting more things onto the secured network is not a good path. And our team has quite a bit of background in the cybersecurity space, so I feel really comfortable advising that that is a horrible idea, and you should probably not do it.
Sounds good. I have the next question from Tom Atkinson. Tom, would you like me to unmute you and you can go ahead and ask your question?
Sure. Yeah. Hi there. Hi there. Thank you very much for this talk. I have a question for you about also about cybersecurity, but and specifically around NERC-CIP. And I understand, if you were delivering this data for planning purposes to a utility, then it could be delivered kind of outside of their SIP environment. But if they're using it, and I remember on one slide you were talking about using utilities using your data for real-time network operations, and that makes me feel like they might be using this data for their, for operating the reliability of the bulk electric system, which is a phrase inside of NERC-CIP that's very carries a lot of weight. And I'm wondering
Yes.
how you overcome those concerns if utilities are using your data for real-time network operations.
Yeah, so that's a really that is a very nuanced question. The short answer is that we currently today don't provide any services that are used for managing the reliability of the bulk system. We focus on the distribution environment, and that's not currently covered by NERC-CIP or equivalent requirements, although I think it's quite likely that that'll be extended in the future, and certainly there's been some conversation about it. Um, it is virtually certain that we will need to fall under NERC-CIP compliance in the future. But as you probably know, NERC-CIP and SaaS or cloud solutions are like currently roughly incompatible. There's some work within NERC to potentially address this, but it's an open question. And I'll tell you quite frankly that I'm hoping that this gets resolved usefully before it really becomes a massive issue for us. In the short term, making sure that anything we feed into in terms of data, like let's say substation forecasts, for example, that might end up impacting the bulk network, that will have to be air gapped very carefully because we are not NERC-CIP compliant today.
Cool.
That helps a lot, and it's exactly actually the answer that I was expecting to hear. That we just keep away from directly having potential to impact the reliability of the bulk electric system.
That's right.
And I certainly have seen Azure, Google, AWS, all the major players are working towards
That's right.
advancing the use of their cloud environments for use by utilities, but I think it is outside of those systems that require SIP compliance at this point in time.
Yep, that's my understanding as well.
Yeah.
Thank you, Astrid, and thanks, Tom. We do have a few more questions, but I'm afraid we have run out of time. We have already exceeded by a few minutes. I do want to thank Astrid very much for an excellent presentation and to Sharon on helping arrange and manage the backend. So this was our first webinar of the calendar year, and we hope to see you folks again at our next webinar. In the meantime, if you want to hear from a certain speaker or a topic, feel free to reach out to us. Thank you very much once again, and have a great rest of the day.
I would just say that thanks so much for the opportunity to share this. And if you would like to contact us, I'm Astrid at camu.energy. So CAMUS .energy. Feel free to drop me an email.
Thank you, Astrid.
All right. Thanks, everyone. Have a great day.